Good day, everyone. Today's topic is all about law of inertia, which Newton's first law. We are Garcia Marigold, Balones Jo Marie, Espigol Jamaica, and Reyes Jimuel Ryan.
Hi, my name is Jimwell. So what exactly is inertia, or also known as Newton's first law of motion? You see, inertia is basically a resistance to a change in motion. Imagine pushing an object like a box. You may move it slightly, but the motion stops as soon as your effort was removed. Like it really don't want to change its position. It's resisting motion. This is the law of inertia. An object at rest remains at rest, just like the box earlier. And an object in motion remains in motion, with the same velocity unless it is acted upon by a net force. I know what you guys are thinking. It seems the first part is the only thing that makes sense since objects normally don't start moving on their own. However, the second part seems unagreeable since if you throw an object, it will eventually stop. The answer to that is the complicated atmosphere of Earth. Unlike space, when we move around, we experience things like wind resistance, gravitational forces, and frictions. These are net forces which slows down motion, and thus requiring a constant force to an object to keep moving. Imagine if there were no forces as such. The thrown object would never stop its motion. This is what happens in outer space. As we go back earlier, inertia is the capacity of an object to resist changes in motion. Basically, it tells us that all things are lazy. If things are at rest, they want to stay at rest. If things are moving, they want to stay moving. For that, force is required to get an object moving, and also force is applied to slow it down or to stop it completely. Now, here's a question. Which object has more inertia? Heavy or light? That's right. Heavy object has more inertia compared to light ones. This explains why bicycles only need gears to keep it moving, and when it crashes to a wall, though I hope not, it will stop at impact, while trains requires huge engines to keep it going, and a lot of force is needed for it to stop. This is because mass is a measurement of an object's inertia. The heavier the object is, the more force you need to make it move or stop. Well, now that we know inertia, what gives? Can we live without inertia? Well, no. Object would stop moving as soon as there was no longer any force being applied to them, which means the earth would stop spinning, light won't move, and the particles would fall apart, which won't be a very fun situation. Now, I did mention earlier about net force. The net force, written as summation of F, is the many forces acted on an object. Therefore, the net force is the sum of all forces. For example, if a brick had a force of magnitude 45 Newton exerted on it to the right, and a force of magnitude 30 newtons exerted on it to the left, the net force in the horizontal would be 50 newtons in total. Newton's first law says that if the net force of an object is zero, then the object will have zero acceleration. It means that the object has a constant velocity. It could be at rest or moving.
Good day, my name is Jamaica and I am one of the members who will solve the two-word problems. For problem number 1, we're asked to look for the force exerted by the surface on the books. We have a given which is the weight of the books that weighs 3 kilograms. So let's look for the forces. You can see in our illustration that our object is at rest means that there is no net external force. We're going to use the equation of summation of forces, whatever the direction it is equal to 0. This equation is also known as static equilibrium. Now let's back to the illustration. Since we have a surface right here, means we have a normal force which is perpendicular to the surface. Also, the weight of the books which is directed downwards. Since we have a y-axis right here, we're going to use the equation of summation of forces along the y-axis is equal to 0. Now let's sum up our forces. Normal force plus negative weight, since our weight is directed downwards, is equal to 0. And because we're looking for the normal force, let's transpose our weight to the right side, and we have a formula of normal force is equal to weight, and weight is mass times gravitational acceleration. Let's simplify our formula to normal force is equal to mass times gravitational acceleration. Now let's substitute our formula by our given values. Normal force is equal to mass, which is 3 kilograms, multiplied by gravitational acceleration of 9.81 meter per second squared equals 29.43 Newton. And final answer for problem number 1 is that the force exerted has a normal force of 29.43 Newton. Now let's proceed to problem number 2. We're asked to look for the tension in the chain. In problem number 2, we have a given, which is the weight of the chandelier that weighs 150 kilograms. Now let's look for the force. Since our object is at rest, means that there is no net external force, but we have a tension, which is the force experienced by the chain, it's directed upwards, and the weight, which is directed downwards. Again, we have a y-axis, so we're going to use the equation of summation of forces along the y-axis is equal to 0. Now let's add our forces all together. Tension plus negative weight, since our weight is downwards, is equal to 0. Since we're looking for the tension, let's transpose our weight to the right side, and now we have formula of tension is equal to weight, and weight is mass times gravitational acceleration. So simplify our formula to tension is equal to mass times gravitational acceleration. Let's substitute our formula by our given values. Tension is equal to mass, which is 150 kilograms, multiplied by gravitational acceleration of 9.81 meter per second squared equals 1,471.5 Newton. So our final answer for problem number 2 is that the tension in the chain has the value of 1,471.5 Newton. So that's it. I hope that you learned something from my demonstration. Thank you.
Good day everyone. So this is my first problem. A 1,000 kilogram spaceship travel in the vacuum of the space at a constant speed of 500 meter per second. Ignoring any gravitational force, what is the net force of the spaceship? Possible answer: 500 Newton, 2 Newton, 500,000 Newton, 0 Newton, and 50 Newton. So, the explanation of the problem number 1 is, in a vacuum, there is no friction due to air resistance. Newton's first law states that an object in a motion stay in a motion unless acted upon by net force. Thus, the spaceship will travel at the constant speed of zero acceleration of 500 meters per second, indefinitely, and the net force on the spaceship must be zero. This can also be shown mathematically. So, the formula of problem number 1 is force equals mass acceleration. So, the mass equals 1,000 kilogram. Acceleration is 0 meter per second squared. So, the answer is 0 Newton. So the second problem is what net force is requiring to keep at a 800 kilogram object moving with a constant velocity of 50 meter per second. So the possible answer is A, 0 Newton, B, 1,200 Newton, C, 12 Newton, D, 120 Newton. The 800 kilogram object is moving at a constant velocity. Therefore, there's no net force of 0 Newton acting on the object. So, the answer of the second problem is 0 Newton. That's all. Thank you po.
So, yung given natin is yung 800 Newton, which is yung weight. So, ang hinahanap natin is yung normal force. Ang formula natin for the law of inertia is the summation of F is equal to 0 Newton. So, para mahanap natin yung normal force, itatranspose natin yung N sa tabi. So, bali magiging N minus weight siya is equal to 0. 0 siya kasi wala siyang normal force. Walang object or na tumagi dun sa rope ng elevator kasi accidental yung nangyari. Since free fall siya, kaya 0 yung net force niya. Dun naman sa 800 Newton, N is equal to weight. Same lang siya kasi hindi naman gumalaw yung tao. So, at rest lang yung tao, kaya 800 Newton lang siya. So, ang sagot is letter A, at 800 Newton and 0. Because the person is at rest in the elevator and the elevator moves at the constant speed, which is no acceleration, so there is no net force act on the person. And after the elevator's rope broke, elevators and the person free fall together, where the magnitude and the direction of their acceleration same as acceleration due to gravity. So there is no normal force on the person. So, my next problem is what net force is required to keep a 500 kilo object moving with a constant velocity of 10 meter per second? So, ang answer dyan is yung 0 Newton. Bakit? Kasi, given na po na 500 kilo object na gumagala with a constant velocity of 10 meter per second. So, ang hinahanap natin is net force. Since wala siyang net force, kasi yun yung hinahanap, which is required, so, di ba, remember, yung formula natin is yung summation of F is equal to 0 Newton. So, hanggang walang net force or walang nagpapagalaw sa object, siya ay 0 Newton. Newton's first law states that an object in motion tends to stay in motion unless if acted upon by a net force. This means that if friction is not being accounted for, there is no net force required to keep an object moving if it's in motion. So the 500 kilogram object is moving at a constant velocity, therefore there is no net force, means 0 Newton acting on the object.